What's up, Mr. Joyce? Today we're looking at antidifferentiation, antidifferent, yeah, by parts. Uh, so this is a way of taking the antiderivative of an expression, and you want to use it when you got two terms inside of an integral that you wanna take the integral of, but they're not really related terms. They're not really the derivative or antiderivative of each other. Yeah, so here we go. This is the formula we use for antidifferentiation by parts. So with your integral that you have, you want to break it up into parts, the part u and dv. And so the way we determined what to put where, yeah, and also this is a way to remember it is the phrase ultraviolet voodoo. So it's like ultraviolet voodoo. That's how it goes. To choose u, we use this mnemonic device lipit. And so it's what it stands for is log, inverse trig, polynomial, exponentials, and trig. So this is the order you want to look through in your integral in order to find out to choose which part of it you want to assign to u. So let's look at an example. So here we have our integral and we have our formula. So what we want to do is first assign u. So using lipit, don't forget to use lipit. We go through log or natural log, or I guess regular log as well. So here, look, it's a natural log. That's the first on our list. We're going to use ln of x. Beautiful. That's going to be u. So the rest of it, dv, that's going to be this 3x and this dx part. And so the integral of the derivative, to get du, we need the derivative of u. So the ln, it goes to 1 over x. And this dx is over here because it's the same as, you would have du dx, but it's the same as multiplying it across. And v, here we take the antiderivative, because it's dv, we're going to go to v of 3x, which ends up being 3 over 2x squared. And so now we have this part of the formula, and we want to plug all this stuff that we just got into here, and it ends up looking like this. And the problem here is that although we took the antiderivative of this, we still have an integral in here, and that's not the way we want it to be. So if we move stuff around here, make it a little simpler, the 1 over x kind of cancels out the x squared. So we're left with this. This is the same thing. And to take the integral of this, it ends up being 3 over 4 x squared, because if you took the derivative of this, it would 2 would come down, make it 3 over 2, just x. And of course, don't forget the plus c. We bring this down, and this is our final answer right here. So that's the first example. Now here we're going to go a little bit more complicated, just a little bit. So we take our little template here. Going through lipit, we see that we don't have any logs. We don't have any inverse trig. We have trig, but we don't have any inverse trig. Trig is over here, so you don't want to get those confused. Now we go to polynomial. We do have one of those. It's t squared. And now this is not an exponential, even though it might look like it. An exponential would be if it was like 2 to the t, because t has got to be up there in the little space, not in the base of the exponential. So now, after we find our u, we find our dv, which is the other part. And that is the rest of it besides t squared, cosine of t dt. And now the other parts of the template, du, take the derivative of t squared, that's 2t, dt. The dt comes from this side over here. And in other problems, we don't need to do in this problem, but you might need to do some algebra here just to get everything the way that you want it. So don't be afraid if you have to move stuff around. And so dv, now we gotta go to v, so take the antiderivative cosine of t, that's sine of t. So that works out nicely. Not any nicer than any other thing. I don't know why I said that. So now with this right side of the formula, we plug everything in, and it ends up looking like this. And we still have this whatever it's called, an integral here that we need to take care of before we write on the AP test or whatever. So let's move stuff around a little bit, take the 2 out. And the thing about here that's a little bit more complicated than the last part is that in order to take the integral, we need to use antidifferentiation by parts again. And this is not terribly uncommon, sadly. And so we get our template here. U, go through Lipit. Again, t is a polynomial, so we use t. dv, it's going to be sine t. Now the derivative of t is it's just 1. So this du just ends up being equal to dt, which is nice. And the antiderivative of sine t is negative cosine of t. And now we get to plug all this into here again. And it ends up looking like this with the 2 on the outside. And we still have an integral. So the antiderivative of negative cosine of t minus the negative ends up being a positive. And at the same time, distributing the 2, that gives us this. And don't forget the plus c. Now we can bring this down along with negative. So these two will change signs. And this is our final answer. I guess you can't really see it. Oh no, how do I... If I don't move, you can see it. There it is. Beautiful. Alright. So that's mostly how to do integration by parts. Just want to say thank you for watching. Don't forget to subscribe and please share with your friends and rate 5 stars. See you in the next video, Mr. Joyce.